The second day of European Science Festival now moves in completely different direction. We are going to field of atoms and molecules. Chemistry is our next topic. We were all children once, and I believe that as curious people, we hugely enjoyed the experiments at chemistry classes in school. This is what we will talk about now. Mr. Tomaž Ogrin, chemist from Jožef Stefan Institute and Lovers of Chemistry Society, prepared some experiments for us that will take us to the exciting world of chemistry labs and nature. Mr. Ogrin and his co-workers from Jožef Stefan Institute will lead the journey. Let's go.
Hello everyone and welcome to the School of Experimental Chemistry. My name is Jan and today we will experiment with chemical reactions as well as with cold and fire. Experiments in the video are performed by me, Evelyn, Tine, Žiga and another Jan. Chemistry is a natural science that studies the composition, properties and changes of matter. One of the best parts of chemistry are definitely experiments, some of which we will show in this video. When experimenting in a laboratory, we require suitable protective gear. We will begin with chemical reactions. Matter changes during the reaction. Some changes are visible instantly. Here we have a reaction between solutions of lead acetate and potassium iodide. The result of the reaction between solutions is the formation of a yellow solid which is made out of lead iodide. If we heat up the new compound, it will slowly dissolve. After slowly cooling it down, it forms golden crystalline particles. While this compound doesn't contain any gold, this experiment is still widely known as golden rain. Name of the next experiment also doesn't make much sense, since elephants don't have any use for toothpaste. It is prepared with hydrogen peroxide and potassium iodide. We continue with reaction between iron 3 chloride and potassium thiocyanate, where a red solution resembling blood is instantly formed. Same reaction happens when we submerge a heart of iron in a solution of thiocyanate, hydrochloric acid and hydrogen peroxide. Next up, we will attempt to prepare a non-alcoholic beer. Even though it looks real, it sadly is not, so we won't be drinking this today. This reaction is achieved by mixing potassium iodide and sodium sulfide with some detergent. The brown color is caused by iodine that is formed in the reaction, while foam is made with detergent. This way we can prepare another non-alcoholic beverage. If we mix solutions of iodic acid, sodium sulfide and starch, we get Coca-Cola. Iodine that is formed during the reaction together with starch forms a dark blue solution. Now we will show reactions that are a bit different. In our next experiment we mixed solutions of glucose, lye and a color called methylene blue. Let's observe what happens if we leave the solution to stand. This coloring is caused by glucose, which is reducing the methylene blue. However, if we shake the bottle, the oxygen in the bottle will turn the color back to its previous state. The charm of this reaction is that once sealed, we can repeat it multiple times. Here we have a similar reaction but with a different coloring compound called indigo carmine. Because of the colors involved, this experiment is called chemical traffic lights. Reaction is similar to the one before, except that indigo carmine has an additional oxidation state and therefore one more color. Like the previous experiment, this one is also repeatable. We have concluded with colorful chemical reactions and are now moving on to gases. As you well know, matter exists in three different states: gaseous, liquid and solid. Under normal conditions, nitrogen is a colorless gas that fills the space all around us. But if we cool it down to almost minus 200 degrees Celsius, it becomes liquid. When dealing with such a cold liquid, it's best not to use protective gloves to avoid ice burns. Let's see what happens to plants if we freeze them with liquid nitrogen. At minus 196 degrees we can freeze almost anything. Here we can see leaves and petals become very brittle. Let's watch a few more examples. Let's see what would happen to fabric if we accidentally poured nitrogen over our clothes. As you can see, the liquid nitrogen flows through the hat's fabric. Once it's heated up back to room temperature, Tine can put the hat on his head. Now what would happen if we tried to freeze a balloon? Gases don't have any defined shape or volume. When on room temperature, the air in balloon takes up all of its volume. But once we cool it down with liquid nitrogen, it shrinks by a lot. As the air is warming up, its volume starts increasing and the balloon returns to its previous size. Now let's see how many balloons we can squeeze in the plastic container using liquid nitrogen. We've counted 14 balloons in a container that can under normal conditions at best take 1. This shows you how much the gases shrink when they're cooled to very low temperatures. Now it's time for some experiments that are best done outside. We've learned in the previous experiment that cold gases expand a lot, so it's not the best idea to close the bottle or it would explode. Even the cork is bouncing around since the pressure in the bottle is increasing. We can use this pressure to create a nitrogen fountain or use it as rocket fuel. Now let's continue with other gases.
Poigrali se bomo s plini.
Naravoslovje je lahko tudi zanimivo, še posebej, če se igramo s plini.
Helium is a lot lighter than the surrounding air, which means the balloon filled with it will fly up. The opposite of that is xenon, which is a lot heavier, and as you can see, it falls faster than the normal air balloon. Here we have another interesting gas called hydrogen. It is the lightest element on the periodic table. If we fill the balloon with it, it would fly like helium. But let's show you why this might not be the best idea. As we can see, hydrogen gas is flammable and can also be explosive. But since it burns out very quickly, it doesn't burn Evelyn's hand. As a precaution, she wet her hand before the experiment. We will continue with fiery experiments. For a fire we need three things: fuel, in this case this will be a small piece of dry bread, oxygen and the source of fire. Our first attempt wasn't very successful, so we will try this again a bit differently. In the metallic cone we've poured liquid nitrogen and put a piece of bread under its stick. On the other side of now very cold cone you can see droplets of condensed air that is rich in oxygen. Let's see how the piece of bread will burn this time. This time the fire is much more intense since we've added more oxygen to the reaction. Now we will try to burn some cotton wool. First we will try the normal one, then we will compare it to the chemically modified one, which is called nitrocellulose. This was so fast, we need to have another look in slow motion. Compared to normal cotton, nitrocellulose burns away completely and leaves no ash. In our next experiment, Evelyn wrote something with a nitro compound. Let's see what she wrote. We all know bright yellow flames. Let's see if using strontium, lithium, boron and potassium we can change that a little. With this experiment we are finishing our presentation. We hope to see you again soon.
So this was the colorful first portion of chemical experiments, but wait, we have more. Mr. Tomaž Ogrin and his co-workers at the Jožef Stefan Institute are now taking us to the place which we all use daily, but do not think about it in a chemical way, mostly. We're going to the kitchen. Just a little warning, the following video is in Slovenian language, but since we all know kitchens very well, I believe that you won't have any difficulties understanding what is going on. So let's go to the kitchen.
Pozdravljeni v šoli eksperimentalne kemije. Tokrat si bomo ogledali nekaj poskusov, ki jih lahko izvajamo v kuhinji. Močno obarvani plodovi, kot so borovnice, maline, rdeča pesa ali rdeče zelje, vsebujejo naravna barvila, ki spreminjajo barvo glede na pH raztopine. To se lepo vidi, če ekstrakte teh plodov dodamo raztopinam z različnimi pH vrednostmi. Barva rdečega zelja se spremeni iz rdeče v kislem, preko vijolične in modre v nevtralnem, do zelene in rumene v bazičnem okolju. Sedaj pa preverimo, kakšen pH imajo alkoholni kis, citronska kislina, mleko, voda, soda bikarbona in pralni prašek. Poglejmo si še, kaj se zgodi, ko kisli raztopini dodamo sodo bikarbono. In kaj se zgodi bazični raztopini, ko ji dodamo citronsko kislino. Tu pa imamo natrijev alginat. Ta gosta raztopina ima lastnost, da polimerizira v prisotnosti kalcijevih ionov. Oglejmo si, kako nastanejo kapljice, črvi in še kaj. Voda je pomemben element v našem okolju. Pomembno je, da je ne onesnažujemo. Predvsem pa moramo paziti, kaj počnemo v naravi. Mnoga bitja namreč hodijo po vodi zaradi površinske napetosti. Le to pa lahko spremeni dodatek detergenta. Poglejmo si, kako to vpliva na delce cimeta in popra na gladini vode. Eksperimenti v kuhinji so lahko zanimivi in poučni. Poskusite jih lahko tudi sami doma.
Okay, we saw what can be done in kitchen. We have one more batch of experiments in the bag. Since we just saw the first sun rays here in Ljubljana just a couple of minutes ago, there is no fog anymore. It's a good time to talk about magic of light and its effects. Video is again in Slovenian language, but it's a visual experiment, so see for yourself.
Pozdravljeni v šoli eksperimentalne kemije na delavnici o svetlobnih reakcijah. Kemijske reakcije so procesi, pri katerih se snovem trajno spremenijo lastnosti. Nekatere spremembe pa so zelo dobro vidne, še posebej, če pride do nastanka svetlobe. Kemijski reakciji, pri kateri nastaja svetloba, rečemo kemiluminescenca. Pri tej reakciji smo uporabili luminol. Ta brezbarvna snov zasije v modri barvi, ko ji dodamo raztopino oksidanta. Žal pa so te reakcije kratkotrajne. Pri sproščanju svetlobe pa ne gre vedno za kemijsko reakcijo. Poglejmo si pojav, ki ga imenujemo fluorescenca. Organska snov, v tem primeru je to fluorescein, absorbira UV svetlobo in jo oddaja v obliki vidne, v tem primeru zelene. Pri tem si moramo pomagati z UV lučko. Najboljši svetlobni efekt pa dobimo, ko kemiluminescenco združimo z fluorescenco. Skupaj z luminolom lahko uporabimo tudi različne fluorescentne barve. Poglejmo, v kakšnih odtenkih žarijo.
So that were some chemical experiments to get us going at the second day of European Science Festival. Mr. Tomaž Ogrin and his colleagues from Jožef Stefan Institute prepared the experiments.